Hello, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 7 of Intermediate R. Now all of the material is here at chriswoods.com/intermediate R, and we're now here on the forward pipes page, which is the percent greater than percent sort of symbol. Now the tidyverse makes heavy use of this R concept of forward pipes. Forward pipes, which are represented by this percent greater than percent symbol, are provided by the Magritte package, which is automatically loaded by the tidyverse. Now a forward pipe forwards the variable on the left into the first argument of the function on the right. So before you were used to be typing something like this, print kitten. So we passed the argument directly into the function, and that printed kitten. But with forward pipe, what happens is the thing on the left, which is the variable kitten, is pushed into to become the first argument of the function on the right. So this kitten forward piped into print is identical as if we put kitten as the first argument of print. Now you might be asking, why is this useful? This seems like much more typing by putting the argument first and then pushing the argument into the function than sort of just writing the argument directly in the function. Well, it's useful because it enables you to chain together lots of functions. So for example, the tidyverse dplyr package provides a function called filter. So if I just type $filter, what we can see is filter is a function which is used to filter packages in dplyr. So there we are. Find filter in the list. There we are. So it's a way of subsetting and selecting out actual functions. Now if I take my cat state tibble, which we have loaded here, I can use the filter function like this. I could say filter from cats, all of the cats where the sex column is equal to female. And this would work like this. It's kind of the traditional way that you would have typed and used a function. But by using this forward pipe, I can type cats, forward pipe, so push cats into filter, and just give me sex equals female, like that. We've achieved exactly the same thing, but now this looks like a much cleaner way of working. We've taken a cats data set and we've passed it through a filter where we're filtering out all of the rows where the sex is equal to F, equal to female. Now we can chain together multiple filters. So doing it like this, when it's just one particular function, doesn't really gain us much. But we can actually chain together multiple filters or multiple functions by putting in another forward pipe. And now we can say, as well as having the sex is equal to female, let's also filter out and have body weight is greater than 2.5. So now what that's done is it's pushed the cat's tibble into the filter function. This is then filtered out and returned all of a tibble which contains all of the rows which are female. This has then been pushed into the next filter function, which has then taken out all of the rows where the body weight is more than 2.5, and it's returned a tibble which contains the result. And in this case, there are only 11 rows in this tibble. There are 11 cats which are both female and where the body weight is more than 2.5. Now, as well as using the filter function, there is another function in dplyr which is called summarize. And what summarize will do is it will summarize the tibble using any function that you pass. So what we can do is we can take our cats, we're going to pass it to filter. Now when you have multiple functions, you noticed here my line was getting longer and longer. If we do shift return, what you'll commonly see is people put each function, one function per line. So our first filter out here, sex equals female, and then you always end the line with the next filter, also with the next forward pipe. We're going to pass that into another filter function now where the body weight is now going to be greater than 2.5. And now if we want to summarize this, we now pass this to the summarize function. And what the summarize function will do is it will create a summary according to the function you wish to summarize by. So in this case, we wish to summarize into a new value called mean, and we're going to calculate the mean by using our calculate mean function that you remember writing before, And now we need to tell it which column of data we wish to calculate the mean for. In this case, we want to calculate the mean of heart weight. So what this will do is we'll basically pick out all of the female cats who weigh more than 2.5 kilograms, and for all of those, summarize that set of cats by calculating the mean heart weight from the heart weight column. And there we are. This has now produced a new tibble which contains one value, the mean, which we set here, and the row 1 is 10.2, which means the mean heart weight of our female cats over 2.5 kilograms is 10.2 grams. Now, of course, we're going to want to assign this value to something, and so it'd be normal here for us to write something like average heart weight is assigned from this. And now that's been assigned. And then, of course, you can then print that. So, for example, if I printed average heart weight, well, you'll notice, sorry. Oh, no, did the wrong thing there. That should have been an HT, misspelling, and I apologise for that. Now I'm going to print average heart weight. That one. You notice it's come as a tibble. Remember before from the first workshop we could say as numeric if we just want the numeric value of it. So there we can see that is the average value of the heart weight in grams of all of the female cats who have a body weight of more than 2.5 kilograms. Now this might look like a very dense piece of code here, but now that you understand that we have these functions, filtering, summarizing using the function that we wrote, and then we're using this forward pipe operator to mean push the thing on the left into the first argument for the function on the right. Hopefully this is beginning to make a little bit more sense. And indeed, when you look through code in R, you'll notice this is a very common thing to see. And if we think back to the vignette that we saw when we were looking through RSeek, you'll have a lot of these lines that look like this. We may even look at some of those things a bit later. So this brings us now down to the exercise on the page. I'd like you to calculate the average heart weight of male cats whose body weight is greater than 3 kilograms. Then I'd like you to calculate the maximum body weight of both the male cat and the female cat that has a heart weight of less than or equal to 9 grams. And then I'd like to look back at the vignette that we found when searching for the product moment correlation and see how much more of this that we have to understand. And again, if you find anything of a function that you don't understand or package you don't understand from there, have a go at installing it and using the question mark in RStudio to get some help. So press pause, and then when you come back from pause, I will show you the answer. Okay, so you've unpaused now, so let's go through the answer. So the very first part of the exercise is we just want now to calculate the average heart weight of male cats whose body weight is greater than 3 kilograms. So remember we have cats, it contains all the data. We're now going to push that through the filter function where we're going to take out all of the cats whose sex is equal to male. And then we want to then pick up body weight as well. So we're going to push that through another filter function where we're going to say the body weight has to be greater than or equal to 3.0 kilograms. And then finally what we want is we want to summarize this and calculate the mean heart weight. So push this through, shift return, summarize. We're going to push the result of that through the summarize function. We're going to calculate the mean as being the result of the calculate mean function on heart weight. And there we are. The answer is 13.2. So the mean heart weight of male cats with more than 3 kilogram body weight is 13.2 grams. Now with the second exercise, we're asked to calculate the maximum body weight of both the male cat and the female cat that has a heart weight of less than or equal to 9 grams. So let's go through. First, we want to find the maximum heart rate for the male, so we'll assign that to a variable called max male. Now that's going to come from cats, the tibble, being pushed through first the filter function where we're going to pick sex equals male. We're then going to push that through the filter function where we're going to pick up all of the heart weights which are less than or equal to 9 grams. And then we're then going to summarize this with the max function, which we wrote. So we're going to do max equals calculate max, and we want to have the max body weight this time. And that's now run. Now if we do the same thing for the female cats, we'll do max female. Again, we're coming from the cats data set. We're going to push that through the filter function, but now we want female cats. We're now going to push that through the next filter function, because remember now we want heart weights that are less than or equal to 9.0 grams. And then we're going to push that through the summarize function, where we're going to find the maximum equals calculate max. So we're looking for the max body weight. And then we're going to print this to the screen. So cat, not related to any of our cats here. Cats printf maximum body weight. Male is equal to 0.2f, percent 2f kilograms. Female is equal to percent 0.2f kilograms. New line character. Then we put in max male and max female. And there we are, the maximum body weight of both the male cat and the female cat, whose heart weight is less than 9 grams, is 2.7 kilograms, which is an interesting result. Now finally, we were asked to look back at the vignette and try and understand that. So I'm going to look back at the vignette. So here it is. And if we look through now, you can kind of understand some of the things that have been written. So remember we had the library function, and the library function was how he loaded things. And there we look, he's loaded Tibbles, ggplot, dplyr, etc. So this has actually loaded most of the tidyverse. Now, R comes with data already included, for example, data set. So in this case, data orange is just loading the example data set. And as Tibble changes, because orange is a data frame, this just converts it into a Tibble. So we know what Tibbles are, and we can see it's now been printed. Now core was that function which we were sort of saw before, and is the thing which calculated correlations. And indeed what we can do is if we type %core, we can see that this is the function that's used to calculate correlations and how it works. That kind of almost makes sense. Now we don't understand ggplot yet, but when we do Introduction to Data Analysis with R, we will cover ggplot. Here now we have orange is now being pushed through group by. So group by is another function which is used to group things by category. We will be covering this in the Introduction to Data Analysis in our workshop. And we've seen summarize. Summarize is basically trying to summarize a set of data. In this case, it's summarizing the correlation of the age and circumference, which is the result there. We have a test, so we don't know what this is, but we could look that up in the help. And then this is tidying up the data. Again, we could look and see what that would be. If we look through here, again, we have nested is now being pushed through mutate. We'll be covering mutate in the next workshop. And then here again, we're pushing orange through nest. Then after we've pushed it through nest, it goes through mutate. Then it goes through unnest. Again, we'll be looking at some of these functions in the next workshop. But you can see how, as I said, it's very common when people are writing R that you'll have a data set being pushed through functions sequentially, with each function being written one on each line, ending with your forward pipe operator. And again, you see this function, this repeated several times, this kind of pattern of data being pushed through function, being pushed through function, one after another until you get the result that you need. So while the individual functions probably don't make much sense to you now, I hope that this pattern assigning to a variable some data that is pushed sequentially through lots of functions is beginning to make a little bit more sense. So with that, we've now finished the very last part of this exercise, and that means now we have finished this part, so now we can come forward and I'll welcome you back in part 8, which is the last part of this workshop.